What does the
Yeah.
study of FRBs, fast radio bursts, pulsar astronomy, and magnetars will do for humans and science? I mean, it's great what you've described about these topics, but how is it important for us humans? And will it help us detect signals from extragalactic regions?
Yeah. These are some great questions, Vivek. And I think the way I'll go about answering this question is I'll start off with defining or explaining what these objects are and
Yeah.
what these events are. As I think by understanding what these objects are, we can better understand why these phenomena occur and why they are important to us. So let's start off with fast radio bursts, as it's the weirdest one of them all. Fast radio bursts, or FRBs, are actually millisecond bursts of energy in the radio spectrum of light. And usually what we find is that fast radio bursts actually tend to come from outside our galaxy. We are actually already detecting fast radio bursts from extragalactic regions. But this is kind of weird since we expect to detect much more powerful fast radio bursts from within our galaxy. But we just haven't seen something like that yet until very recently. And I believe that was in 2020. Um, Fast radio bursts were actually discovered by a person called Duncan Lorimer back in 2007. So they're actually a very recent discovery. And since then, we've detected hundreds of fast radio bursts. And one such observatory in Canada called the Chime Observatory is able to detect dozens at a time. And it's just fascinating. Now, at first, many people thought that fast radio bursts were deliberate signals from aliens, but as we all know, scientists tend to reserve that theory to the last point because you can pretty much explain anything with aliens. Um, and so now we realize that based off that discovery, which I mentioned back in 2020, of a FRB, fast radio burst-like signal within our Milky Way galaxy, the most likely theory is that fast radio burst is actually being caused by magnetars, which I'm just going to talk about right now. Magnetars are actually very similar to neutron stars and pulsars. In fact, magnetars are a subcategory of pulsars. Sorry, not pulsars, neutron stars. Neutron stars are actually primarily made of neutrons with a small layer of plasma on its surface. And the reason why it's got such a structure is because neutron stars are crushed so tightly that all the protons and electrons literally merge together to form neutrons. This is due to the immense pressure and density, which you just don't see on the surface. And as the neutron star spins, it creates giant magnetic fields, and these magnetic fields are due to the fact that electrically charged particles move in a certain way. And whenever electrically charged particles move, they generate a magnetic field. And so these are just neutron stars, but magnetars are just the neutron stars with some of the strongest magnetic fields. They could be millions of times stronger than Earth's own magnetic field. I think sometimes even billions. Pulsars are also a subcategory of neutron stars, except what happens is that their magnetic fields actually squeeze their radiation, their electromagnetic radiation, into these beams, and these beams sweep across the sky. And to a distant observer like us, it seems as if the pulsar turns on and then off. And you can think of them like lighthouses. And so, to a distant sailor, the lighthouse turns on and then off at a very periodic rate. And I think by understanding these phenomena, we can better understand, the stellar evolution, so the evolution of stars, the life cycle of stars, just understanding what these objects are in general. But also it's just fascinating to know for us humans. As humans, we have been wondering about the universe for quite some time, and so I think it makes sense to also for us to also question certain stuff about pulsars and fast radio bursts because this is very human to us. It's very human for us to ask questions and then get certain answers, and also formulate our own answers and theories. So that's what I think. That's what I personally think about, why we should observe these phenomena. Now, before we move on to the next set of questions, I'd just like to mention how these objects, how do we actually observe these objects and events? Because we actually observe them in the radio spectrum of light. And as you can tell, we use radio astronomy, and radio astronomy is a part of astronomy where we focus on the radio spectrum of light. And this is extremely important if you want to look at, for example, like, hydrogen emissions in galaxies, or you want to look at, like, cosmological redshift, which can be used to determine the age of the universe, and also these other events which I've been talking about. And so we can use radio astronomy to understand more about these objects, because this is the part of the electromagnetic spectrum where these objects tend to emit the most. And so that's what we at the Molonglo Observatory Synthesis Telescope are doing. This telescope is actually a radio telescope. And so we observe these pulsars and fast radio bursts, all the time. It's one of our specialities, if you will. And the funny thing is that we can actually see phone calls and other human-related activity in these in this data sometimes, and it's really funny to see that because it just sort of screws up our data, and like we're like, oh no, we have to clean up the data.